So hello everyone, welcome to my channel again. So today we will solve this physics problem in electricity, which is related to the capacitors, and it's a very interesting problem from book Randall Knight, 26th chapter and 6th problem. So let's go. Initially, let me read the given information for us. Initially, the switch in this figure is in position A, and there is a capacitor C1, C2, C3. Initially, C2 and C3 are uncharged, and then the switch, which is responsible for isolation of this circuit, is flipped to position B. Afterward, what are the charge on and the potential difference across each capacitor? So problem is quite simple. So we have here what we have here. Let me turn on my pen. We have here C1, C2, C3. Initially, they are uncharged, C1 and C3. So we need to find, firstly, when in position A, A position. Is this color comes for you? I don't know, but I want to change this color to black. Yes, total black. So it will be black. Black is my favorite color. So we have here battery, which is charged to 100 volt, and the C1 capacitor 1, 15 farad, microfarad. I need to find here charge on this capacitor. We can find it by multiplying these two given values. If we multiply, it's just simple. How many columns? It's 1500 microcolumns. Yeah, so we have initially this charge here. When the switch in position A. Why do we need this charge? Because only this charge plays role in our problem. Yeah. No any charges from outside. Only this charge from this C1 capacitor. So and then we need to switch it to position B. In position B, what will happen? We need to firstly connect it, find total in order to find total, and as you can see, C2 and C3 are connected series. Yeah, because C2's tail is connected to C3's head tab, and as it's series, we can find it by this formula if we have two capacitors. Since this formula, we write this 20 microfarads multiplied by 30 microfarads, and adding them, if we will add, it will be 50 microfarad. And from calculations, we found that it's 12 microfarad. It's total in this line. After this, as we can see here, the series is total is parallel to the first capacitor. Yeah, they are parallel because the end connected to end, the head connected to head. Yeah, this This is my idea here. C1, C2, head and head, tail and tail, and I need to here find total capacitor, total capacitance. I can find it by parallel adding here, parallel addition, C1 plus here C, not C2, I C series here, C series. It will be how many? 12 microfarad plus how many? 50 microfarad. It would be 27 microfarad. It's total. As we have here total charge and total capacitance, we can find here total what voltage, yeah, across this circuit. So we can find total, this total voltage here. It's this Q total divided by C total, and we found it above. It's 1500 microcoulomb, and here is 27 microfarad. From calculations, we can find that it's 56 voltage here. We found a total voltage across this circuit, and then we need to find here Q1, yeah, Q1, because here is Q1 and the Q2, Q3, and the V1, V2, V3, yeah, because this is total. This is not Q1, this is total. Sorry for my mistake. This is total. Yeah, this is total. We can find Q1 by this way. Q1, C1 multiplied by this V total. Because C1 and the series capacitor, which the two series capacitors are parallel, and their voltage are the same. Yeah? C1 is 15 microfarad, and multiplied by this voltage. From this, we found 833 microcoulomb. Is it clear? I hope it's clear. And this is for Q1. This is for Q1, and for Q2 we use the same formulation here, but we need to use here the series capacitance. Yeah, this is series capacitance, because when capacitors are connected seriously, their charges are the same, but voltages aren't. Yeah, so it will be series multiplied by what value? Yeah, the final, the total, or here the series capacitance was 12 microfarad multiplied by 55 voltage. Yeah, according to the calculations, we found that it's 666 microcoulomb. We found a Q2 charge on the second capacitor, and after we need to find here Q3. Since the two capacitors are related in one line, are lined up in one line, their charges are the same. So Q3 equal to Q2. We have found here all charges, and I need to find here voltage across the circuit, and as you can see, V1 will be equal to the total voltage. Why? Because the C1 and the series, this one, these capacitors are connected parallel, and their voltage are the same. Yeah, and since it's equal to this total, we can find just V2 and the V3. Why? Because they are connected seriously. When capacitors are connected seriously, their charges aren't the same. Yeah, their voltage aren't the same. Their charges are the same because. So V2 is equal to what value here? Q2 over what? C2. Then here conduct this calculations. After conducting here, the result will be 33.3 voltage here. It's our answer. This is the same formulation for V3. Q3 over C3 will be Q3 was the same as a Q2. It is as 30 microfarad, and the result is 22.2 volt voltage here. So we found all unknown values here. Yeah, if we add here all charges, then the result will be this 1500 microcoulomb. And if we will add this all voltages across the circuit, the result will be 55.5 voltage. Yeah, because the total value across the circuit are constant. Yeah, this problem is quite simple, but here is a key factor to understand that they aren't charged. If they are charged, the scenario will be different. So we have charged here one capacitor, and after charging one capacitor, we just switch the flip. Yeah, switch the flip, and the flip plays a crucial role here. So the main part is understanding this what's happening in circuit. Yeah. Because if there is no flip, the scenario will be different, quite different. If it's clear, if there are no questions, subscribe my channel, and if you like this video, you can put this like symbol. So thank you for watching and paying attention.